Hello children, we are starting the third topic from the first chapter of class 11th and the topic is error analysis. And my suggestion is that before you solve the numericals, please go over the chapter, go over the topic and the formulas. Now let's start the numericals. The first question is, a length is measured as 50 centimeter using a meter scale having a least count of 0.1 centimeter. What is the absolute error in the measurement? Always keep in mind that whenever a device is given, the least count is same as absolute error. Whenever any device is given, the answer is very simple. Least count would be given in the question and that is same as the absolute error. So 0.1 is the least count and hence our answer is option number C, 0.1 centimeter. Now the next question, question number 2 says the radius of a sphere is measured as r is equals to 7 plus minus 0.1 centimeter. Find the percentage error in the volume of the sphere. We have to find the percentage error in the volume. So let's see the expression of volume of a sphere. Expression is V is equals to 4 by 3 pi r cube. This is the expression, and in this expression we can see 4 by 3 and pi are constant, so we can say that V is directly proportional to r cube. We can use this relation to find the error. Now we know that the expression for fractional error is delta V by V is equals to 3 delta R by R, where delta V is absolute error in volume and V is the value of volume. Same here, delta R is the absolute error in radius and R is the value of radius. And here in the question, two values are already given, 0.1 which is our delta R and 7 which is R. So we will put these values in this equation and we will get 3 into 0.1 upon 7. On solving this further, let's use the calculator. 3 into 0.1 divided by 7 gives us 0.0428. So the answer here is 0.0428. Now this is the relative error. In order to find the percentage error, we need to multiply this value with 100 because we have just found the value of delta V by V. We need to multiply this with 100, then we will get the value of percentage error. So delta V by V is 0.0428. 0.0428 into 100. This gives us the answer as 4.28 percentage. So the answer is 4.28, which is close to 4.29. So we are going with option C. Now next question is question number 3. Two quantities are measured as A is equals to this and B is equals to this. If Q is equals to A by B, what is the percentage error in Q? Four options are given. Now here Q is equal to A by B is the expression that we have, and we have to find the percentage error in Q. Whenever we have division or multiplication, this is how we find the expression for relative error. Delta Q by Q is equals to delta A by A plus delta B by B. Even if we had multiplication between A and B, we would have written this kind of expression. So now let's solve it further. We have to find the percentage error. Let's put the values. Delta A is 0.2, A is 4, delta B is 0.1 and B is 2. So let's put these values. It will give us 0.2 upon 4 plus 0.1 upon 2. Let's simplify it further. 0.1 upon 2 and this will be 20. So 0.1 upon 2 plus 1 upon 20, which gives us 1 upon 20 plus 1 upon 20 and 2 upon 20, which further gives us 1 upon 10, which gives us 0.1. So 0.1 is equals to delta Q by Q, which is relative error or fractional error. Now in order to find percentage error, we need to multiply the fractional error with 100. So we will multiply 0.1 with 100 and the answer will be 10%, right? So answer is 10% and C option is correct. Now next question, question number 4. The time period of a simple pendulum is given by 2 pi t is equals to 2 pi under root L by G if the percentage error in length is 2%. Percentage error in length is 2% and in G is 1%. In acceleration due to gravity, it is 1%. Then the percentage error in T. We have to find the percentage error in T. Expression given here is T is equals to 2 pi under root L by G. I have one more suggestion. You can pause the video right after the question, solve it by yourself, then you see the solution. Now in this expression, we have 2 pi as our constants. We can ignore these two terms and we can further simplify this as t is proportional to L to the power half and G to the power minus half. Now when we form the expression for relative error, we will get delta t upon t is equal to half delta L upon L plus half delta G upon G. And if you are my student, then you will definitely ask the question that, ma'am, why we are not putting the negative sign over here and why are we putting a positive sign? This negative sign is always ignored in the expression of relative error because errors are always added. So even if the powers have negative sign, we will only use the number, we will not use the sign. Okay, so let's solve it further, put the values. Okay, we can convert this expression in the expression of percentage error, right? So first let's convert it into the expression of percentage error. Delta t by t into 100 is equals to half delta L by L into 100 is plus half delta G by G into 100. Now we have this information given in the question. What information? The error in length is 2%. Percent error in length. This is 2 and this is 1 as given in the question. This is 1. So we are putting these values in this expression and we will get the expression as this is equal to half into 2 plus half into 1. Now it becomes very simple to solve this. On further solving it, you will get 1 plus half and 1 plus half gives you 1.5. So the final answer is 1.5%. Delta t upon t into 100 is equal to 1.5%. So the answer is option number B. Now next question is question number 5. A physical quantity is calculated using z is equals to a square b cube upon under root c. The percentage errors in A, B, C are 1%, 2% and 4% respectively. What is the maximum percentage error in Z? We have to find the percentage error in Z. So first of all, let's write this expression down over here. A square b cube under root c. When we simplify it further, we get z equals to a square b cube c to the power minus half. Now, for the expression of relative error, we will write delta z upon z is equal to 2 delta a upon a plus 3 delta b upon b plus half delta c upon c. As you can see, negative sign is given in the power, but we are still using plus over here. Now let's convert these expression into the expression for percentage error. So this becomes delta z upon z into 100 is equal to 2 delta a upon a into 100 plus 3 delta b upon b into 100 plus half delta c upon c into 100. Now these terms, delta a upon a into 100, delta b upon b into 100 and delta c upon c into 100, these values are already given in the question. This is the percentage error in A, which is given 1. This is the percentage error in B, which is given as 2. And this is the percentage error in C, which is given as 4. Now we will put these values in the expression and we will get 2 into 1 plus 3 into 2 plus half into 4. We will simplify these and we will get 2 plus 6 plus 2. This will be 8%. So delta z upon z into 100, which is the percentage error in z, is 8%. The answer is B. Today I have brought a bonus question for you, and this is a bonus question. Try to solve it, and there's a hint as well on the next page. You can use this expression, expand it, and then form the expression for relative error and then percentage error to find the answer. Thank you for watching the video.